Welcome to the Deep Dive. This is where we take really complex stuff, boil it down, and give you the core insights, basically making fascinating things easy to grasp. Today, we're digging into the world of antique restoration. It's quite a process. Specifically, we're looking at an early 20th century German tobacco cutting machine. Master Pina's restoration of it, actually. And this thing wasn't simple. It had, a complete gear acceleration system, pretty advanced for its time.
Oh, absolutely. That's what's so fascinating. These machines look kind of straightforward, but the engineering, especially for the early 1900s, it was sophisticated. You're looking at a real blend of mechanical smarts and material science, considering the era. Really impressive.
Yeah, and our main source is this fantastic video Master Pina made. It shows everything step by step. You really see the work involved. So our mission today, for you listening, is to unpack this whole restoration. We'll break down the steps, figure out why certain choices were made, and maybe uncover some hidden gems along the way. And hey, if you like these kinds of deep dives into restoration stories, definitely consider subscribing to our channel so you don't miss out.
Okay, let's get into the machine itself. What are we looking at component-wise? The video shows, well, there's a main body frame, looks like aluminum, a wooden base, the cutting blades, obviously, plus a feeding system, that big hand crank arm.
Right, and the way it worked was you'd put the tobacco leaves, scraps, whatever, into that wooden chute. It clamps down. Then you turn the crank, and it does two things at once. Drives the cutting head and a roller that feeds the tobacco forward. It cuts these strips, maybe 2 to 5 millimeters wide, and they drop out the bottom.
2 to 5 millimeters. Why that specific width? Does that tell us something? It really does. That width is pretty much perfect for what they called short filler cigars, or even cigarette tobacco, which was really taking off then. Mass production was becoming a big thing. This machine was built for that kind of work, definitely a workhorse.
And you see that when Master Pina starts taking it apart, I mean, the complexity is just, wow. He completely disassembles it, all those parts laid out. It's clearly not going to be a quick job.
No, not at all. It signals a really deep, complex restoration ahead. It's more than just cleaning. It's bringing it back from the dead, almost.
So where does he begin? With the mainframe, right? The aluminum body. First thing is sandblasting with white corundum.
Yeah, and sandblasting here, especially with something fine like white corundum, it's not just about getting the gunk off. It prepares the surface, takes off corrosion, old paint, but gently.
Yeah.
And importantly, it reveals details like that German Augsburg protection manufacturing factory mark. That probably wasn't visible before. It also shows up any hidden cracks or flaws in the metal.
Okay.
After that, he moves on to traditional grinding and truing.
Truing. What does that involve?
Truing is all about making sure the surfaces are perfectly flat, perfectly aligned. Back to the original geometry. Super important for everything to fit back together correctly.
Gotcha.
Then there's manual chamfering, putting a little angled edge on things. And finally, using steel wool with WD-40. That gives it a specific finish, treats the surface. It's all chosen for function just as much as looks.
Something that really jumped out at me from the source was this mention of aluminum's self-passivation. What exactly is that, and why does a restorer need to know about it?
Self-passivation. It's a fantastic property. Basically, when aluminum meets air, it naturally forms this incredibly thin but very dense and hard layer of aluminum oxide. It's transparent, so you don't see it, but it acts like a natural shield. Protects the metal underneath from corrosion. It's kind of amazing.
So it protects itself.
Exactly. And a good restorer, like Master Pina, understands this. He'll choose cleaning methods, like the sandblasting and steel wool, that don't destroy that natural protective layer. You wouldn't want to use harsh chemicals that strip it bare, leaving it vulnerable. He's working with the material's properties. It's quite elegant, really.
Moving inside the machine now. There was a damaged part, right? A sleeve bearing.
Yes, for one of the moving shafts. It was pretty beat up. He decided to replace it with self-lubricating brass.
Self-lubricating? Does that mean it doesn't need oil?
Well, yes and no. This kind of brass usually has something like lead or graphite mixed into the alloy itself. As the shaft spins, tiny amounts of that lubricant get transferred, creating a slippery film. It's definitely better than, say, plain copper, which forms a much weaker oxide film.
But he still added oil holes.
Precisely, because self-lubricating helps. But for a machine doing real work, especially repetitive cutting, it's not enough on its own. Adding those oil holes allows for proper lubricating oil, which is far more effective and lasts longer. It ensures the best performance and protects the new part. Smart move.
Okay, let's switch materials. The wooden feeding part, that looked like it was in rough shape.
Oh, it was. Really significant damage. And Master Pina made a tough call here. The bottom section was just too far gone, too rotten, too broken. Instead of trying to patch up something fundamentally weak, he decided to, well, abandon it.
Wow, okay. So he saved the top part.
Yeah, the top part was less damaged. And his repair method for that was fascinating. Cleaned it with an air gun first. Then, and this is the wild part, he used dental floss.
A dental floss, seriously?
Seriously, he packed it into all the little holes and cracks, like tiny, intricate stitches inside the wood, creates these internal patches. Visually, it's quite something.
Oh.
Trimmed the excess, sanded it smooth. Then, for reassembly, he didn't use the old weak spots. He drilled new holes, used iron pegs for strength. Very clever.
And finished with linseed oil.
Finished with linseed oil. It's a classic choice. Brings out the color, protects the wood. It's historically appropriate for this kind of machine, too.
And speaking of wood, the base was completely replaced. And this involved a modern technique, didn't it?
It did.
Yeah.
That's a great example of mixing old and new. He used camphor wood, which is a nice stable wood. But to cut the pieces for the new base, he used laser cutting.
Laser cutting on an antique restoration.
For structural parts like the base, it makes sense. You get incredible precision, perfect edges, much faster and more accurate than trying to do complex cuts by hand.
Okay.
Then he assembled it using traditional wood glue and iron nails. But crucially, he pre-drilled the holes for the nails.
Why is that so important?
Prevents the wood from splitting, especially near edges. It's a fundamental woodworking step for strong joints. Skimp on that, and the base could crack later. He also ground a bevel on it, just a slight angle, to give clearance for some of the rotating parts.
And then finished it to match.
Yep. Walnut-colored dye, then linseed oil again, protects it, makes it look consistent with the restored wooden feeder part. Looks great.
And by the way, if you're finding this interesting, or maybe you've worked on a similar project, do share your thoughts or stories in the comments. We genuinely love hearing from you. All right, let's get to the sharp end. The blades. Critical part. The originals were toast, right?
Completely unusable. So new ones had to be made from scratch. Forged from tool steel. He mentions Mark Bolchek steel in the source, which sounds like a specific brand or quality grade indicating good, reliable carbon tool steel.
And making blades isn't just cutting out the shape, is it? There's heat treatment involved. Annealing.
Exactly. Annealing is the first key step after rough shaping. You heat the steel up to a specific point, then let it cool down really slowly, often buried in sand to slow it even more.
What does that do?
It softens the metal, relieves internal stresses from when the steel was made. Basically, it makes the steel much easier and safer to work with. Drill the mounting holes, get the final shape right. If you skipped annealing, the steel might be too brittle, could crack when you try to work it.
Yeah.
It prepares the steel for what comes next.
So it's like relaxing the metal before you stress it out again.
That's a good way to put it, because the next step is hardening.
Okay.
After the blade is shaped, you heat it up again, quite hot this time, and then cool it down very rapidly, quenching it in oil or water usually.
And that makes it hard.
Super hard, and strong and wear-resistant, essential for a cutting edge. But there's a catch.
Oh. It becomes brittle.
Exactly, like glass hard, but shatters easily. So you can't stop there. The final heat treatment step is tempering.
Which is like baking it.
Pretty much. Baking it in an oven at a much lower, very controlled temperature for a set time. This reduces the brittleness, makes the steel tougher, more resilient, so it can handle the impacts of cutting without chipping or breaking. It's this careful balance between hardness for the edge and toughness for durability. It's real metallurgy.
Wow. There's so much science in just making a blade. And after all that heat treatment.
Then comes the precision work. Grinding it to the final exact dimensions, polishing the surfaces, which helps reduce friction and makes the edge last longer, protecting it from rust, maybe with oil or another coating, and finally the crucial step, sharpening it to a razor edge.
He also made other tiny adjustments, didn't he, to the shaft and things?
Yes, absolute precision. He polished the main central shaft and slightly reduced its diameter so it would fit perfectly inside that new brass sleeve bearing he made earlier. No friction, smooth rotation, and he made a new brass shim, just a thin piece of brass to sit between the blade assembly and the main body.
What's that for?
To eliminate any tiny bit of wobble or play. Ensures the blade cuts perfectly straight and true. He shows a before and after, and you could really see the difference the tiny part makes. It's meticulous.
Okay, moving on to the part that actually feeds the tobacco into the blades. The feed transport roller. Its shaft was also damaged.
Severely. The original shaft was unusable, So Master Pina machined a completely new one and chrome plated it.
Chrome plating for durability.
Durability and corrosion resistance, yeah, good choice. The aluminum roller itself just needed a good cleaning and maybe some minor truing, but the drive gear on that roller, that needed serious work. After sandblasting, it spent time on the lathe, reshaping surfaces, making sure it would mesh perfectly, and he had to make another custom brass sleeve to ensure it fit perfectly onto the new shaft. Lots of custom fitting.
You mentioned pins holding the gears. 2 types.
Right? It's quite clever. One pin lets a gear spin freely on the shaft. It acts more like a guide or spacer. The other type locks the gear to the shaft. So when the shaft turns, the gear turns. That second type is what actually transmits the power. Shows careful thought in the original design for both function and probably easier assembly-disassembly.
And finally, even the hand crank assembly got the full treatment, down to the handle.
Absolutely, nothing skipped. The wooden handle part was sanded smooth, then oiled for protection, standard procedure, but done well. And it was missing its end piece, a little cap or something. So Master Pina machined a new one out of brass. Matches the other brass parts, looks great. Secured it properly.
And the big wheel.
The large drive wheel, yeah. That got sanded, polished up beautifully, then chrome plated like the new shaft, really makes it pop. The crank arm itself was sandblasted, ground, trued up, and then he applied a cold bluing finish.
Cold bluing, what's that?
It's a chemical process. It turns the steel this deep, rich blue-black color. It's not paint. It chemically alters the surface, provides good rust protection, but also gives it this fantastic, textured, antique look. Really enhances the aesthetic.
Okay, so every single piece is restored, cleaned, maybe remade, it's all back together. Let's revisit what this thing was for. Short filler cigars.
Right. Understanding that helps appreciate the machine. Short filler means cigars made with chopped tobacco, tobacco pieces, scraps, not the long whole leaves you find in premium cigars.
Which raises the question, why make cigars like that? Why was that important enough to build machines like this?
Now we get into the industrial side of things. There were huge advantages, especially back then.
Okay, like what?
Well, number one, cost. Using chopped tobacco, using the scraps meant much less waste. You used more of the valuable tobacco leaf. That brings production cost way down. Number two, and this is key for this machine, short filler is perfect for machine rolling, like cigarettes.
Mass production.
Exactly. Suddenly you could make cigars much faster, with less skilled labor. Mass production became possible, making cigars cheaper and available to way more people.
Any advantages for the smoker?
Yeah, potentially. Short filler cigars often have a lighter draw, can deliver flavor maybe more directly. They might not have the complex evolution of a long filler, but they offered a good smoke. And crucially, at a much lower price point. So it really opened up cigar smoking to a wider audience.
So the machine comes together, the restoration is complete.
And the before and after is just stunning. You see this rusted hunk of metal transformed into, well, a functional work of art. It gleams.
And the test. Does it work?
It does. He tests it using dried vegetables, since getting tobacco might be tricky. But you see it slicing cleanly, smoothly. Hearing that mechanism work back to life after probably decades of silence. It's fantastic. Early 20th century German engineering, running perfectly again. It's a real testament to the original build quality and, of course, to the restoration skill.
So, wrapping this up, what's the big takeaway here? Looking at Master Pina's work, it's obviously about saving a piece of history, right? But it feels like more than that.
I think so too. It's about appreciating the ingenuity that went into these old machines, the clever mechanics, the understanding of materials, and it's about the craft of restoration itself, the patience, the problem solving, the sheer skill needed to bring something like this back.
It really makes you wonder, doesn't it, how many other old machines or even everyday objects have these kinds of stories locked inside them?
Yeah, stories of innovation, maybe forgotten ways of doing things. It shows how dedication and skill can literally make history tangible, make it work again. It's pretty inspiring.
And here's a thought to leave you with. Think about the lifespan of this machine. Built over a century ago, restored and working again. Compare that to so much of our modern tech that feels, well, disposable. What can we learn from these old mechanical wonders about durability, about repairability, about creating things with lasting value? Something to ponder. Let us know your thoughts on that, or share any similar restoration stories you know down in the comments. We really do value your input. And please, to keep getting these deep dives into fascinating restorations and more, do consider subscribing to the channel. Thanks for joining us.